All right, so we have Benjamin Mathews, a senior culinary student, and he is presenting on aquaponics at Nicholls State University.
Thank you, Chef. My name is Ben, and this is Aquaponics, the future of sustainable farming. So what is aquaponics? Aquaponics is a combination of two processes. Hydroponics, the process of growing plants in water instead of soil by using added nutrients and special lighting. And aquaculture, the rearing and harvesting of fish, shellfish, or algae in all types of water environments. So hydroponics and aquaponics both existed separately at first, and relatively recently the techniques were merged to create what we know today as aquaponics, cutting edge of sustainable farming. The combination of techniques makes for a unique symbiotic relationship and efficient farming of both plants and fish. So aquaponics being an evolution of the hydroponic system, there are many similarities. So aquaponics is a closed system. There's no additional chemicals. It yields fish as well as produce. There's higher labor and cost to establish the system. There are more possible points of failure. Hydroponics, many additional chemicals are needed to grow the plants. It only yields produce. It's lower labor and cost to establish and fewer possible points of failure. Both systems yield large amounts of produce. They're environmentally friendly, are cost and space efficient, and are the future of the agricultural industry. So we're also going to have the hydroponic towers in the greenhouse at Nicholls. And I believe that housing both systems under the same roof gives us a unique opportunity to study both and see firsthand the similarities and differences and the pros and cons to both systems. So how does aquaponics work? Fish are stocked in a large tank. It can be a variety of species of fish. A lot of people use carp. You can even use koi. We're going to be using channel catfish here at Nicholls. A pump moves the wastewater from the fish tank through a biofilter. So in the biofilter, the fish ammonia attracts good bacteria that convert the ammonia and the nitrites into nitrate, and that is pumped into the grow bed for the plants. So the bed is filled with a grow media or growing rafts can be floated on top of the water. The grow bed gets planted and the plants use the nutrients from the fish waste, cleaning the water in the process. The clean water is pumped back into the fish tank and the cycle continues. Benefits of the aquaponic technique. So compared to traditional farming, aquaponics grows 6 times more food per square foot, uses 90% less water through the water cycle, produces food year-round, especially when housed in a greenhouse like it will be here. There's no dirt, so it requires little weeding and little to no pest control. It grows produce twice as fast. It produces fish alongside the vegetables. And it requires less land, and the land does not have to consist of fertile soil. So environmental benefits. With aquaponics, there are many environmental benefits, especially compared to conventional farming and other methods. So water conservation, it uses 90% less water than traditional methods. So since the water is being cycled and cleaned constantly between the fish and the plants, it's an incredibly efficient system. Energy conservation, even when using grow lights, it is incredibly energy efficient. And since all the energy used in aquaponics is electric, green and renewable sources can be used for power such as solar and wind. Land conservation, since it grows 6 times more densely than commercial farming, way less land is needed to produce the same amount of produce. And aquaponics can easily be established in urban areas as well, even utilizing abandoned warehouses, things like that, to produce the fish. And it protects our rivers. So since there's no dirt, there's no pests, no pesticides are needed, no chemicals are needed, nothing is wastewater, no runoff into our rivers and lakes. It's an incredibly clean system. No system is truly perfect. Aquaponics is no exception. There are a few disadvantages to this system compared to other ones. The cost of construction is slightly higher than most other systems. There are more possible points of failure because it is slightly complicated. You're raising fish and vegetables at the same time. There's a lot of pH balancing that needs to be done. And there are some limitations when it comes to growing certain crops. So most of what is produced through aquaponics is leafy greens, herbs, things like that. Root vegetables are pretty much impossible, so like potatoes and carrots and things like that can't really be grown, but it does produce large amounts of other produce. So why Nicholls? I think that an aquaponics system would be a perfect addition to the Nicholls new greenhouse on campus. Nicholls biology and culinary programs will benefit greatly being able to study this and use the produce. Fresh local produce will be available in culinary lab classes. Biology will be able to study and help maintain the system. We will be on the cutting edge of sustainable farming research, and there is opportunity to expand the system in the future if we wish to do so. So my plan for Nicholls' venture in aquaponics is fairly simple. I've reached out to Kenneth Russ and Paul McGay at Enterprise Aquatics in Baton Rouge. They are industry experts and have agreed to assist me in setting up our system. They will provide the system and all of its components, as well as professional advice throughout the process. The system will consist of 16 square feet of floating raft grow beds and will house up to 30 channel catfish. The produce will be sent to the John Falls Culinary Institute for labs, and additional product will be sold to the community. Biology and the Bridge Independent students will also be assisting in the project, providing opportunities for hands-on learning. I believe that the system will be operating at full capacity in under a year, and a strong possibility for expansion in the future is possible.
Okay, great, Ben. Sounds like a really exciting project.
Yeah, exactly.
We've talked about this quite a bit. Some things that I'd like to ask you about, first thing would be cost. You're saying it's more expensive than other non-traditional methods. So what are we looking to get this set up?
So, Kenneth Russ at Enterprise Aquatics was a huge help in this process. I met with him last week and we discussed the cost. He's going to be able to provide us with all components of the system for $1,300. And that's everything included: grow beds, the first 50 pounds of fish food, the fish, everything.
Okay. So the fish, what are we feeding the fish?
So the food is specific to aquaponics. You can't just go to your local ag store and get pond food for catfish. It doesn't have the nutrients they need to keep housing the system, such as this. 90% of the nutrients will come from the fish waste to the plants, just naturally. And aquaponics fish food is fortified with the last little bit of iron and calcium that the plants would need. We're going to be also purchasing that by private aquatics in Baton Rouge. It's $1 a pound. The fish, the amount we're going to be housing are going to be about 22 pounds per month, so $22.
Okay. And then can you describe the filtration system that's used on this?
So the specific filter that we're going to be using is the typical pond filter. So the water is going to be pumped from the fish tank into the bottom of the filter, and it's going to go through 3 levels of sponges with decreasing or increasing density. So the bottom level is going to filter out big solids and so on and so forth. And also in this filter is going to be where the bacteria grow that do that critical conversion of ammonium nitrites to nitrate for the plants. There's a lot of surface area on the sponges, so we have much room to. So as the water is filtered, solids are taken out. It's also converting that into the usable nutrients for the plant.
Okay. And what kind of maintenance is required on that filter?
So for the filter, once a week, it needs to be, there's a siphon at the bottom and open it up, and it drains all the solids out. You take the sponges out the top, check, make sure everything's good in there. You don't want to close them out or anything, so all the bacteria are growing. So you just put the sponges back in, as long as there's no solids, you can do it.
And what do you do with the solids?
So this is something I would like to study a little more here after we get the initial system established. So speaking with Kenneth Russ from Enterprise Aquatics, one thing he's working on is taking those solids in that wastewater, putting it into a separate tank, aerating that tank. It has the same good bacteria in it, so they're converting that solid waste that would mess up the pump and filtration system in the closed system. And so as it's aerated and converted, it produces basically liquid fertilizer. And you can take that and use it to grow a completely separate batch of plants in pots. It kind of expands the capabilities of the system a little bit.
Okay, so it's it would augment the watering of like our bird beds that we have outside of the building here. Okay, fascinating. Does the fact that we're using fish in this system affect the taste of the products that we're growing?
It doesn't. So basically, we're taking a natural process that happens in the wild every day and condensing it down into a closed system in our greenhouse. Animal waste, fish waste is being converted into plant nutrients every day. We're just doing it on a small scale. So it's completely natural. The produce tastes great. I've tried some from our aquaponics system. I have no off for it.
We would also be harvesting catfish out of this. How does that work?
So the ratios for the system is about weight of fish and weight of food to square footage of grow bed. So in this system, we're going to house ideally around 30 pounds of catfish. And so as the fish exceed that weight, it's not exact, so they can be up to 5 to 10 pounds over. As they exceed that weight, we're going to be taking fish out and harvesting them for meat. So if it gets to 35 pounds of fish in there, it's 1 pound per catfish. We'll take 5 catfish out and harvest them for about 30. Cycle will continue.
Okay. And how's that catfish going to taste?
It tastes great. There's no mud, no blue-green algae in there. It's all super good food. They're being grown in the system, so it's great tasting meat.
Okay. And so again, we're in March right now. If we were able to get started, let's say April 1st, when do you think we could start harvesting plants out of the system?
So the initial cycling, so getting the system started, getting the bacteria established, takes about a month. With the cycling, get the person online. And from there, we'll be able to put all of the fish straight into the system. We're not going to go for the full 30 pounds right away. So it's not going to be operating at full capacity, but I think we can start getting heads of levels out of the system. 2 months, 2.5 months.
So, maybe June. Okay. All right. Well, it sounds like a great idea, and looking forward to having this implemented.
I'm excited about it.